Welcome to Electronics Techie. So in this video we discuss about 3 to 8 decoder. So 3 to 8 decoder, I just give what are the inputs and what are the outputs. If you want the complete explanation of decoder, you can comment on it. I make separate video about decoder. If I give complete explanation of this decoder, then it takes too long of this video. That's why I skip the decoder concept. I just give the block diagram and explanation in simple manner. So if you want about detailed explanation, you can comment on it. So 3 to 8 decoder is nothing but it is one of your combinational circuit. It has 3 inputs and 8 outputs. So when you are going to give the input 3 inputs means we get 8 combinations. So for every combination means for different of 8 combinations, one of the output is going to be select. Means in multiplexer, demultiplexer we have select lines. According to that the input is going to be selected to the output. But here what are the input combination? According to that input combination the output is going to be select. So if the combination is 0 0 0, then output 1 is going to be select. So the truth table is like this. So 0 0 0 1 0 0 1 1. So 1 0 0 1 0 1 5 and 6 7 like that. So according to that, it is the output 1 and 0 2 3 4 5 6 7 like that. So for first 0 combination, the output 1 is going to means O0 is going to be select. Remaining are going to be 0. And if the combination is 1 means first input is going to be 0 and the second input is 0 and third input is 1 means the O1 is going to be select. Remaining are going to be 0. So like that for different combination of input, one of the output is going to be select. Remaining are going to be 0. So this is the main concept we are going to design in this video. So you just look into the design code means it start with module and end with end module. Know about the syntax and module followed by module name. So here decoder is our module name. We can route anything. So according to our understanding, we make it as a decoder. So what are the inputs? So they are the inputs of 3 bits. So that's why we represent 2 down to 0 means 2 1 0. That means 3 bits. So 2 down to 0 of in out. Reg 7 down to 0 of out. So what is our output? So there are the 8 bits. So that's why we written as 7 down to 0. 7 down to 0 means 8 bits. So 8 bits. So why are going to use reg means there is a always block. Whenever the always block and initial blocks are going to be done, what are the variables inside you are going to use? See, out variable is going to be used in this always block. That way you make it as out as a reg data type. So if you use any other variable in this always block or initial block, those are going to be mentioned in the reg data type. So here out is the variable we are going to use in the always block. That's why I make out as a reg data type. So always at the rate star is nothing but our sensitivity list. So if any change in the single bit of input also, it is going to be executed. So it is a sensitivity list. So begin followed by out. So initially out is going to be taken as 0. If you don't take it as 0, it defaultly take as a unknown number. So you have to go to take this as a 0. So if you take it as 0 means the output is going to be 0. So next first initially our out is going to be assigned as 8 zeros. So next case of in. So you know about case statement. So what is the variable you are written in the case? So that value is going to be written. So that value is, if it is equal to this value, this line is going to be executed. So if in value is equal to 3 down b 3 tick b 0 0 means, so 3 represent the number of bits here. So b is represent the what is the type of binary or decimal or number system. Type of number system it represents. So if in value is going to be equal to 0 0 0, then out value is going to be assigned as for 0 0 0. So out of 0, so means O0 is going to be 1. 1 tick b means 1 is assigned to the out of 0. Remaining all bits are remaining as same as previous thing. So here okay, this is the LSB part O out of 0. So this value is going to be 1. Remaining all are make it as 0. So output will be 0 0 0 0 1. So why I represent underscore means after 4 bits you are going to assign the underscore. It take it as nothing. So no need about this. So it takes like this. So whenever there is a more number of zeros or more number of ones, it will give you clarity. How many after 4? Okay, 4. It is very easy to understand for 4 zeros or 3 zeros. It is too clumsy. So that's why use underscore. If you don't use also, no problem. So for different combinations, out variables are going to be assigned here and default. So if you don't give 0 0 0 for any one up to 1 1 1, you give 0 0 x. So there is no combination here in this. So default. So it is a default case. So if you give x x 0, so these are the default case. For any default case except these 8 combinations, any values are going to be, out value is going to be 0. So case is end with end case, and always begin is end with end keyword, and module followed by end module. So it is our test bench code. It is very simple to return. So module followed by module name here. So inputs are in reg data type, so outputs are in void data type. So what are the variables you are used in the initial block or always block? Every time I say that it should be a reg data type. So that's why I mentioned that in as a reg data type. So I think you all understand about why inputs are reg, means we are going to use those inputs in the initial block. So what are the variables you are going to access in initial block or always block? That should be a reg data type. So that's why I use as a reg. Otherwise you can use wire also. So because of initial block I make it as reg. I think you are going to understand. So decoder, so you have to instance the design code here. So design code, how you are going to connect these test bench code and design code, means by using this instance line. So design code module name, so followed by instance name. DUT is our instance name, design under test. You can write any name, your name also you can write. So it is a standard one. DUT means design under test. So port list, so port list by order. So by port list or order or name you can use anything. There is only one input and one output, so they are the two variables only. That's why connect by order. Means order means the what is the first we are going to assign in the design, means here is the in, here is the out. So for that, according to that we are going to assign the variables here. So it is about the port connection. In initial block you are giving the different input combinations. So it is our input combinations. So it is our input combination. First I give 0 for the input and give some delay. So again I give some default case, and again I give delay, and again I give 3 as the input for decoder, and then after some time, so after if you want any if you want to stop the simulation, after some time after some delay I want to stop the simulation by using this finish keyword. For stop the simulation we simply write the $finish braces semicolon, and initial begin is end with end keyword, and module end with end module. So after that you are going to run, means the output is seems like this. So out is when you are going to elaborate the out variable, it will give the all bits here. So first I give initially 0. So 0 means what is the out of, means out of 0 is going to be 1. See here, out of 0 is going to be 1. So you can see the values here. Out of 0 is going to be value 1. So for any default case out is going to be 0. See, the out value is going to be 0 here. So 0. So why it represent like, means so first 0 it is represent hexadecimal format. It represents 0 means 0 0 0. So another 0 means 0 0 0. So 8 bits. So 3. So third combination I give as 0 0 1. Here in the test bench see 0 1 1. So 0 1 1 is nothing but 3. So the combination is 0 8 8, means see 0 0 0 0 underscore. So 8 means 1 0 0 0. So out of 0, out of 1, out of 2, out of 3. So out of 3 value is going to be 1. See here, this line is going to be, so here, this line is going to be 1 here. So these yellow line values are going to be given here. So if you want these values, you can simply scroll double tap on this scale, then these values are executed in this space. So I think all you are understanding about the waveform. That it is our schematic diagram. So it's just a block of decoder, and then is the 3 inputs and outputs. So it represent in a single bit, means you can take single variable. In that single variable you are going to give us different index. So there is a 8 bits, there is a 3 bits. So here it is our decoder, 3 to 8 decoder. The other 3 inputs for and 8 outputs. It is very simple than multiplexer, demultiplexer, those are. So because there is no select line, only only inputs and only outputs. So it is very simple. If you have any doubts till now, you can comment on it. If you don't understand any particular thing also, you can comment on it. I make separate video for the separate thing also. So no need to hesitate about asking anything. So I think it's fine. So thanks for watching. If you have any doubts, you can comment it, and then bye.